So today's lesson is going to be on scientific notation. Scientific notation is something you're going to see throughout science at Modern Day. All classes pretty much use it, and use it in math sometimes as well. It's just a way to write long numbers in a very short, compact format. You may notice sometimes when you see web links online. The websites used to be really long, and now sometimes they're shortened into shorter links. It's kind of like that. It's just something that's used by scientists. Now, the whole sole purpose of it isn't just to make numbers shorter. It's also to show precision and how accurate an instrument is, and it could be used to give a good indication of significant digits, which we will cover next week. But so for today, I just want to kind of show you how we use this shorthand and how you can convert numbers back and forth from scientific notation. Now, scientific notation, you may know, you may have seen this before, is in base 10. So all of our number systems, our regular number systems, are base 10, which means every 10, it kind of goes into a flip over mode where the number flips and you carry it over. And you learn this really early when you do math. When you do 23 plus 38, you add that 3 and that 8, you have an extra 1. You can only go up 10 numbers, 0 through 9, and then you have to go to the next place value. And that's what our number system is based on. And scientific notation is based exactly on this. So the notation you will always see is times 10 to the x, where x is some kind of number. That is scientific notation. So let's dive right into it. Let's take a number and see if we can put it in scientific notation. And there's only a couple rules that you really need to follow to do this. So I'm just going to give you an example, and then we'll look at those rules. So let's say I have the number 3,432. I want to put this in scientific notation. Well, the answer is 3.432 times 10 to the third. Now, you can do that really quickly once you get the hang of scientific notation, but I want you to notice a couple things about this number. First thing, that digit right there is followed by a decimal point. With scientific notation, you never have a number greater than 9.99999. It never is 2 digits. It's always 1 digit. So regardless, it doesn't matter how many numbers you have. You could have like 3,254,000,000, this super long number. When you write it in scientific notation, you're always going to have 1 digit. And that's one of the hard, fast rules. And really one of the only ones. And then we'll just write that same number, 3432, and we add times 10 to the third at the end. Now, what the 10 to the third does is it tells us to move it 3 times to the right. Now, that's one way to think about it. If you think of 10 to the third power, well, 10 times 10 times 10, that equals 1,000. Now, with scientific notation, the way I think of this is 10 to the 3. That means 3 zeros, 10 to the 3. 3 zeros right there. If you multiply something times 10, essentially you're just moving a decimal over. So let's say you have 2.4, you multiply that by 10, that equals 24. Most of you can probably do that in your head. But really all you're doing is you're taking that decimal point and you're moving it over 1, because you've just moved it over by 1 10. Now up here when I write 3.432 times 10 to the third, I'm doing multiplying by 10 3 times. So basically what I'm doing is I'm taking that 3.432. If I was to multiply that times 10 to the third, I would move that decimal over 1, 2, 3, because I'm multiplying by 10 3 times. That is going to give us the number 3,432, which is the original number we had over here. So that's all scientific notation is. There's only a couple rules. Just remember it has to be a single digit before the decimal point, and after that you have to have times 10 to something. You could even write, like if you have the number 2.65. Technically, you could write that in scientific notation as 2.65 times 10 to the 0. 10 to the 0 is 1. You're not multiplying any 10s. You're not adding any zeros. It's the same exact number. Okay, so that is just the basis of scientific notation. Now let's look at a couple examples of this. Let's say I have a big number. Let's say 2, 6, 5, 4, 0, 0, 0. So let's write this in scientific notation. So first of all, we're going to change this into a decimal with only one digit. So I'm going to take the exact same numbers. I'm going to rewrite it as this: 2.6540, 0, and 0. That's the first step. Now, all I have to do is figure out how many spaces I'm going to have to move that decimal point to get back to my original number. So I'm going to count here. 1, 2, 3, 4, 5, 6. So I'm going to have 10 to the 6 right here. Or conversely, I could have 10 to the minus 6. Now these two things, positive 6 and minus 6, they're both 6s. And when you move your decimal point, we're going to figure out which way we're going. Are we going to a bigger number or a smaller number? The way I always remembered it is that when you have 10 to the x as positive, where x is positive, that equals a big number. When 10 is negative, so when 10 to the x is negative, it's a small number. And what I mean by that, it's less than 1. It is a decimal. It can be way less than 1, actually, depending on how many negatives you have there. So that's one way you can remember it. Some people remember it as, okay, if it's positive, you move it to the right. If it's negative, you move it to the left. Now, you can do it that way, and a lot of people do. The reason I never personally did is because when I go backwards from scientific notation, it was easy for me to get confused. So the bottom line is you're just going to want to use whatever's good for you. And on the assignment on the worksheet, there's scientific notation examples, and the whole first page shows a good way of doing it. So you can follow that, you can follow this, but just figure out a way that works for you. There's lots of ways to do scientific notation. And kind of stick with it. Once you understand it, you will completely understand it. So let's go back to my example here. For me, I use positive 6 as big, and 10 to the negative 6 is small. So when I write my decimal out here, you can see the 2.6540000. I know I'm moving it over 6. I'm going to look at my original number. Is my original number big, or is it small? Well, that's a pretty big number. That's 2,654,000. So I'm going to choose the positive. And my answer would be 2.654000 times 10 to the 6. Now, you don't always have to put those zeros at the end. Sometimes you will, sometimes you won't. It depends on something called significant digits or significant figures, and we're going to talk about that next week. But if you want, for this worksheet, if you just want to write that is 2.654 times 10 to the 6, feel free, because those zeros really don't mean anything. They're just placeholders for this particular example. Okay, that's how you would do scientific notation. Now, let's look at a small number. Let's look at something like 0.000318. Okay, let's look at this number. Now, to write this in scientific notation, I have to rewrite the number as a number between 1 and 10. It has to have a single digit in front of the decimal point. So what I'm left with is 3.18. I'm not going to put those zeros in front of it because those zeros really are just placeholders. They don't really mean anything. They're just shifting things over into the tenths place or the hundredths place or the thousandths or 10,000ths place in this example. So ignore those zeros in the front. They're called leading zeros. And I have 3.18. Now I'm going to see how many spaces I got to move my decimal point. I got to move it 1, 2, 3, 4. I'm going to look at my original number. Is that a big number or a small number? That's a very small number. It's way less than 1. So I'm going to write it as 10 to the negative 4. And it's that simple. Big numbers, numbers greater than 10 are going to have a positive exponent on your x, and small numbers, numbers less than 1, are going to have a negative exponent on your 10. So that's how you do scientific notation. Now let's go backwards. Let's go the other way. Let's take a number. I'm going to just write a random number here. I'm going to write 6.38 times 10 to the 4th. Okay, well, let's take a look. My 10 to the 4th, that exponent is positive. That means it's going to be a big number. So I know this number is going to be bigger than 10. It's going to be a pretty big number. So now all I have to do is write it 6.38, and I have to move over 4 spots. Because I'm making a big number, I'm going to want to go to the right. I want to make it big. So I'm going to go 1, 2, 3, 4. So the decimal point is going to be here. Now notice there's a couple extra spaces here. There's empty spaces. All you got to do is fill those in with zeros. So what you're left with is 63800 or 63,800. And that's all there is to scientific notation. You're just counting left or right. Conversely, say I have a small number, 2.72 times 10 to the negative 13. This is something that's really small, maybe a super small measurement from a chemical instrument. So how would I do this? Well, I would write my 2.72, and I need to go to the left a bunch of spaces now. Minus means small number less than 1. So I'm going to want to move it to the left. So let's take a look. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to have 0.0000000000272. It would be an extremely small number because I've moved it over 13 to the left. Now, this is why scientists tend to use scientific notation. Let's say an instrument that is measuring the amount of a chemical in, let's say, some groundwater. We're looking for some toxins or something, some pesticides or something. Sometimes things are detected in very low levels. There are compounds that are toxic, even if you only have a couple of them, like in parts per billion, they can be toxic. So your instrument might spit out a number like this. Let's say you have to do a calculation with that number. What is it easier to do a calculation with? This big long number right here. Let me get rid of this thing down here. So imagine you have this big long number, right? Oops, let me change this to set back to 272. Let's say you want to multiply this by 45. Man, even with a calculator, I mean, punching in all those zeros, most calculators don't even go that big. And if you try to do this by hand, that would be really tricky. But if you were to do like this, all of a sudden things become a lot more manageable. And it doesn't matter which way you go, bigger or smaller, scientific notation is really useful. So on this assignment, all we're going to do today is to move things left or right. On the worksheet, you're going to have to take numbers like 63,800, and you're going to have to convert that to scientific notation. Or you might have numbers like 6.38 times 10 to the 4th and convert that back to a decimal. So remember, if you have times 10 to a positive number, it's a big number. If you have times 10 to a negative number, it's a small number. You can use left or right. You can use many different methods of using this or doing this. That's just what worked for me. It's just the example I'm going to give you today. So look at the assignment. Try to do as many of those as you can. And that's it for today. And we will see you on Friday. And Friday, we'll just have a Zoom meeting and catch up. And we'll talk about a few things, and we'll talk about a couple projects we're going to do. Take care and have a great day.